We're now going to do Jefferson's for all three of those problems, Jefferson's method. All right, you'll notice that I went ahead and copied the pages and the quotas from Hamilton's into Jefferson's along with that first standard divisor. If on the assessment I ask you for multiple methods of the same example, the same pages, the same counties, whatever the case may be, you don't need to redo these first couple steps because they are the same for every single method. Finding the total, finding the standard divisor, finding the quota for each of the people or each of the counties. So I copied those straight over. I didn't recalculate them. I just copied them down. Now we go into how Jefferson and Hamilton's may differ, all right, or any of the methods. This next step is where it may differ. For Jefferson and Hamilton's, the initial is actually the same. We cut off the decimal values. So 4, 4, 3, 2, and 2. And we check how much that adds to. Just like it did in the last in Hamilton's method, it adds to 15, the cutoffs. But now where we differ between Hamilton's and Jefferson's is in Hamilton, we just added the extra 3. In Jefferson's, if this number is too low, we have to lower the divisor and try it again. If the number's too high, you have to raise the divisor and try it again. So 126.667 was the original divisor. I'm going to try 125. Let's try 125 as the new divisor. And look how I gave you the room. Note how I'm showing this here because this is the table I would give you to show your work on an assessment. All right, I would give you multiple columns, multiple tries so that you can have more room. I might even give you more columns and you might not need them all. Maybe you guess really well on the first go of it and you don't need the extra places to show your work, but you might need to try these multiple times. So it was too small. We needed to lower the divisor, so we're trying 125 instead of 126.67. The different quotas, remember the way you find the quotas is the total for that county or person divided by the divisor. So 612 divided by 125, that's 4.896. 545 divided by 125, that's 4.36. Going on, 3.648, 2.024, 2.312. All right, there are my new quotas. Again, with Jefferson's, you cut off and you see if you have the right amount of votes. 4, 4, 3, 2, and 2. That's 8, 10, 15. That's not right. My apologies. I knew we increased, but I just read wrong there. Sorry. 378 divided by 125 is 3.024, not 2.024. So 4, 4, 3, 3, and 2 adds up to 16. Is this the right amount of candies to award? The answer is no. We needed 18. Again, still too small, so we have to lower the divisor more. Maybe next you try 120. Maybe next you try 124, but I'll tell you right now that that's not low enough. I'm going to jump down to 110. All right. The quota being, again, each of these individuals divided by the new divisor. And I just guessed 110. I'm sure when I originally made my notes, I tried a few more probably. I probably didn't jump immediately to 110. And again, if I'm not going to give you like a hint as to what you should jump to, I will give you extra columns so you have the space to show that work if you need to. All right, with the divisor of 110, our quotas would be 5.5636, 4.9545, 4.1455, 3.4364, and 2.6273. With Jefferson's, you cut off 5, 4, 4, 3, 2. We add these together. We have 9, 13, 16, 17, 18. So this is our final allocation. I know I wrote initial at the top, but I could rewrite final if I wanted, and I would just copy these all over into that final allocation column. All right, pause, go to problem 8. Try Jefferson's method on there, go to problem 9. Try Jefferson's method on there. and then go ahead and play or skip to the end of the video or check my online solutions to see if you got the same thing. I'm going to continue through and do them pretty quickly. All right. Again, I copied everything over. The divisor for the standard divisor was 7,200. Those were the quotas that came from it. For Jefferson's, the initial is the cutoff. But when we added all of those together, we got 48. We needed 50 representatives, 50 seats. So this is too low, meaning we have to lower the divisor. Maybe we'd try 700 next. All right, maybe we try 7,100 next. You don't want to step when you have big numbers like this for the divisor. You don't want to decrease by 1. That's not going to be enough. So try decreasing by 100 or 200. I actually jumped down, again, to save time. I'm going to jump down to what I know will work. But normally, like if I was doing this for the first time, I probably wouldn't have jumped down to 6,900. I would have gone to 7,100. And then if that still wasn't enough, maybe I would have jumped 200 down to 6,900, but I would not have gone 300 right off the bat down. All right, it's just not how I would typically operate. You do have to experiment with these a little bit. Right, with the divisor of 6,900, our quotas would be 8.696, 4.522, 10.029, 11.826, 17.101. Cutting off, like we do for Jefferson's, you cut off the decimals, then you add them together and see if they add up to the proper amount. You'll see here that they do add up to 50. So this is our final allocation. We can stop here. This is the final allocation. Note that it's possible to jump too far. If I jumped all the way down to 6,000, my number of seats would end up being more than 50. All right, and if that happens, if you have more than the number of seats, you have to increase the divisor. If you have less than the number of seats, you have to decrease the divisor. It goes in the same direction, which I know feels a little counterintuitive. If it's too low, lower the divisor. If it's too big, increase the divisor. It really does go the same direction as what you're trying to accomplish. All right, number 9's Jefferson. Once again, I already copied the populations and the standard divisor quotas, the quotas that come from the standard divisor. That first divisor was 14,521.1207. All right, and those were the quotas that came from that standard divisor. For Jefferson's, we cut off the decimal values. We cut off the decimal values for those initials, 9, 22, 37, 17, 29. We add them together to see what they equal. In this case, that was 114 seats or representatives, but we needed 116 seats for this problem. So this is too low. 114 is too few, which means we have to decrease the divisor. So this number needs to be decreased down. Next, maybe you try 14,500. Maybe you try 14,400. Again, to save us time, I'm going to jump to one that I know works, 14,200. And this is not the only divisor that would work. There's a lot of things, but probably a lot of variations near this that would still get you to the proper number of seats as well. All right, but with this divisor, so remember the way we're finding these quotas is each population divided by the divisor. Our quotas are going to be 9.768, 23.020, 38.617, 17.556, and 29.662. For Jefferson's, we cut off those decimals, 9, 23, 38, 29. And adding all of those together, we get 116 seats, which is the proper amount, meaning this is my final allocation. That's where I stop for this problem. And those are our examples of Jefferson's method.